All right, last lesson of Math 3 Term 2 Unit 1, binomial expansion with Pascal's triangle. So if normally we're expanding a binomial, which is something that has two terms in it. So for example, if I had x plus 6 to the third power, I would have to do x plus 6 times x plus 6 times x plus 6. I would have to distribute these two first, giving me x squared plus 12x plus 36. Then I would have to multiply this by x plus 6, distribute. Okay, so you see what I'm getting at. It's kind of a big deal and it's a long process. So what Pascal's triangle does is it gives us a shortcut to get from this to the answer, which is awesome. So first let's explore what Pascal's triangle is. This is Pascal's triangle and this is how you create it. So first you start with 3 ones, 1, 1, 1 in a triangle like that. And the way that you build it is you put ones all the way down the sides and then you are going to add the two numbers to create the number below it between. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 4 is 5, so on and so forth. And I'm not doing a very good job, it's kind of sloppy, but the good news is they did it for me right here, okay? So notice that in Pascal's triangle, the row is always going to be the second number in the list or in the row, okay, the row number. So this is row 0 because there's a 0 here. This is row 1, this is row 2, row 3, row 4, row 5, row 6, row 7, row 8, etc., etc., etc. It's also important to notice that this is completely symmetric, meaning if I read it forwards and if I read it backwards, it would be the same. 1, 3, 3, 1, 1, 3, 3, 1, 1, 5, 10, 10, 5, 1, 1, 5, 10, 10, 5, 1. And that's really important to make sure that it helps us so we don't make mistakes later, but it's also the beauty of Pascal's triangle. So you're probably wondering, okay, cool, Meryl, how does this have to do with expanding binomials? Well, let's take a look. Let's do the example problem right here, x plus y to the 4th power. So I have x plus y to the 4th power. So here's my example, expand this sucker. Okay, the first thing that I'm going to do is I'm going to look at row 4 because I have a 4th power. My exponent is 4, which means I look at row 4. The numbers of row 4 are 1, 4, 6, 4, 1. So I'm going to write those out. 1 plus 4 plus 6 plus 4 plus 1. And notice how I'm leaving space there, okay? Then I'm going to look at each of these variables. So I have 1, 2 terms because it's a binomial. I have 2 terms. The first one is x. So I'm going to start with x and I'm going to put x in each one. Now the exponent here is 4. So I'm going to start with x to the 4th. Then in the next one I'm going to do x to the 3rd. I'm going to go descending. X to the 2nd, x to the 1st, x to the 0. Now, would it matter if I did x to the 4th here first or if I did x to the 4th here first and went backwards? It doesn't matter because it's symmetric, 1, 4, 6, 4, 1, so it doesn't matter. The only thing that really matters is that our exponents always add up within the term to be 4. So now I have y. I'm going to start here, y to the 4th. And notice 0 plus 4 is 4. Then I go descending, y to the 3rd. 3 plus 1 is 4. Y to the 2nd, y to the 1st, y to the 0. Notice the exponents are always going to add up to be 4. So if you start with 1 at the exponent 4 on one side, you have to start with that other one with the exponent of 4 on the other side. So they go that way. So now all I'm going to do is I'm going to simplify. So I know that y to the 0 is simply just 1. Anything to the 0 power is simply 1. So I have 1 times x to the 4th. That just gives me x to the 4th. Plus 4 x to the 3rd y. I don't need that exponent of 1. Plus 6x squared y squared. Plus 4x to the 1st, I don't need the exponent, y to the 3rd, plus I don't need the 1 times y to the 4th. And that's the expanded polynomial. Isn't that a lot easier than doing x plus y times x plus y times x plus y times x plus y and then distributing it all out? And plus, when I distribute it all out, I often make mistakes too. So this is a really quick way to do that. So this is expanding binomials using Pascal's triangle. It's awesome. So let's go ahead and let's do an example with a number. So this example is x plus 2 to the 6th power. So I'm going to write it over here, x plus 2 to the 6th power. Now this one has a number in it, so this is just going to have one extra step. So first things first, I need to go back to Pascal's triangle and I need to look at row 6. It would be really important to have this Pascal's triangle in your notes, by the way. Row 6 is 1, 6, 15, 20, 15, 6, 1. So let's go down to the question I'm working on. Whoa, where did it go? The question I'm working on, what, right here. So 1, positive 1, positive 6, positive 15, positive 20. What was next? 1, 6, 1, 6, 15, 20, 15, 6, 1. So positive 15, positive 6, positive 1. All right, so now I'm going to do the same thing I did before. So I look at my first variable, and it is an x. So I'm going to do x. My exponent is 6, so I'm going to do x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. Now I go to the second term, which is positive 2, and I'm going to start from this side. 2 to the 6th, because the degree is 6, 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. All right, now that I've done that, I'm going to simplify. So in order to do that, I know 2 to the 0 is just 1, x to the 0 is just 1, so I can cancel those. But I also now have these numbers in there. I don't just have variables. So in my answer, my coefficients aren't going to be 1, 6, 15, 20, 15, 6, 1. They're going to be changed because of these numbers. So this is when you have a number in the binomial. So first let's look at this one. This is simply x to the 6th, right? Then I have a 6 here, an x to the 5th, and a 2 to the 1st power. Isn't that just 2? So I have a 6 here and a 2. So let's multiply those together. That's going to give me 6 times 2 is 12, x to the 5th, plus I have a 15 here, and I have 2 squared here, which is 4. So I have to do 15 times 4, which is going to give me 60, x to the 4th. Plus, here I have a 20 and a 2 to the 3rd. 2 times 2 is 4, times 2 is 8. So I have 8. 20 times 8 is going to be 160, and I still have the x to the 3rd. Plus, here I have 15, and I have 2 to the 4th, which is 16. So I'm going to do 15 times 16, which is 240, and I still have that x squared. Plus, I have a 6 here and a 2 to the 5th, which is going to be 32. So 6 times 32 is 192, and I still have that x to the 1st power, plus 1 times 2 to the 6th. Well, 2 to the 6th is 64, So it's just going to be 64. This is my answer. So you need to make sure if there's a number in that binomial that you simplify it with it. And I know this looks crazy, you guys, but it's 100 times easier than doing x plus 2 times x plus 2 times x plus 6 times. Okay, so I hope this helps with your binomial expansion using Pascal's triangle. This is one of those things that the more you practice it, the better it becomes because it's just a pattern, all right? If you have any questions, go ahead and ask. Keep up the good work, you guys. Great job with Unit 1.